Hi, everyone, and thank you. Good morning, good evening, or good afternoon, wherever you are in the world, and welcome to Artificial Intelligence for Every Developer. I am John Paolo, and the work I'm doing here at IBV, it's a lot of work about emerging technologies, and this involves artificial intelligence. Artificial intelligence is a field that since some years ago, it was restricted to boundaries of some scientists. With the work Microsoft and other big companies and the involvement they are making in artificial intelligence, it's now possible to get artificial intelligence and develop artificial intelligence. Every of us can develop artificial intelligence. So let's dig into the slide and let's start talking about this course because we have a lot to talk and not that much time. So about this course, the takeaway you will get is you will understand at the end of the course, you will understand what artificial intelligence is. So define it in the context of science, what machine learning is, and also what deep learning is. The way you actually can develop artificial intelligence, the way you can infuse artificial intelligence in your application to make them smart. You will also understand the core concept of deep learning, some of the technology, and some of the terminology and the algorithm. And we will also develop some cool stuff. So let's go ahead. Artificial intelligence is something that it's there since long time ago, since early 40s. In 1959, the concept of machine learning was introduced for the first time. But what is literally changing the world is the introduction of deep learning. Deep learning was introduced before 2012, but actually the first time it was used to train a computer, to make a computer intelligence, it was 2012. In 2012, and this was reported in the major journal in the United States, like Wired, New York Times, there was a group of scientists that was able to build a network of 60,000 computer processors with 1 billion connector and let it browse YouTube looking for cats. So the brain simulation was exposed to something like 10 million randomly selected thumbnails from YouTube over the course of 3 days. And after being presented with a list of 20,000 different items, it begins to recognize cats using deep learning algorithm. This date is really important because, it was 2012 and they had to make a network of 60,000 computers to make this happen. Why? This is all about computational power, and I want to make a note on this because this is something that maybe not everyone realize, but it's something very important because let's start from 1995. In 1995, we got 5 million transistors on a chip, and it was the population of New York City at that time. 1995, it was the launch of the first Intel Pentium with Windows 95 was also launched, and everything was changed in the world. 2005, the number of transistors on a single chip grew to 160 millions. This is the population of the entire East Coast. And it was the era when the Pentium 4 was coming out, internet was growing, and there was the mobile thing was near the corner. 2010, we got 1 billion transistor, and this is the post-iPhone, post-iPad connected world, and we were doing gesture and voice recognition in our living room with 150 bucks. 2015, we got 7.5 billion transistor on a chip, and that's a transistor for every single man, woman, and child on Earth. How big it is? How big this growing is going on? 2 years later, 2017, we filled up another planet. It took 30 years to fill up to New York City, and just 10 years to fill up the entire world. That's the compute power that is changing the face how we will see the world in the next couple of years. And that's why now is the right moment to jump in the artificial intelligence field and start developing for it. So, artificial intelligence. Artificial intelligence, it's a branch of science, and it's the science of making things smart. It can be defined as human intelligence exhibited by machine. And this is in general artificial intelligence. The state of the art, what we can do today with artificial intelligence. Artificial intelligence today is like something, don't you think to the artificial intelligence of Terminator. We are not there. We won't be there. Artificial intelligence today, it's a form of narrow AI. A system can do just one or few defined things as well or better than a human. And this is important. So, it can recognize something or maybe detect a credit card fraud in real time. There are several use cases in artificial intelligence, like object recognition, speech, creative, like style transfer, as you see in this picture. On the left, the original picture, in the middle, the style that will be transferred to the original picture, and on the right, you will see the result. How cool is this? So, but in common, we can say today that you can infuse any of your application, any of your services, any of your website with artificial intelligence to make it become smart. Let's talk about, we defined artificial intelligence. Let's talk about machine learning. Machine learning can be defined as an approach to achieve artificial intelligence through systems that can get better the more you run them. Machine learning involves teaching a computer to recognize patterns by example, rather than programming it with specific rules that we are usual for doing it, if then else. No, machine learning is something different, so we will teach it to recognize a pattern, and this pattern can be found within data. and basically is creating algorithm that can learn complex function from data and make prediction out of them. So as we said, machine learning is predicting stuff, and it's intelligent because it takes some data to train the system, learns pattern from this data, and then classifies new data it has never seen before. These data are classified the way that the result is given us like a best guess of probability. So the difference between traditional programming, if we can take an example, maybe from a spam filter, and if you were asked to develop a spam filter today with classical development, let's say C# development, what you are going to do? You're making a long list of if and then, so a long list of rules. With machine learning, we can train a computer, a system, to classify some email, and then this system is able, once it's trained with a lot of data, is able to apply the learning model and classify the email in this case. Deep learning can be generally defined as a technique of implementing machine learning. One such technique is a concept known as deep neural network. Let's say deep learning is the context of deep neural net, and deep neural network is where our code, our artificial intelligence code is written on. So the ways of developing artificial intelligence, we have several ways, actually 3 ways of developing artificial intelligence. The first one, the easy way, using artificial intelligence as a service. So by using the Azure Cognitive Services and using it as a service, we have a bunch of services covering a lots of domains like vision, speech, language, knowledge, search, so on. To use it, it's very simple. I'm covering really fast this part because this is not the core of our course today. By the way, just to give you a glimpse, and you can find a lot of course also on Channel 9 how to use cognitive services. Basically, we said that it's just using a service, so we just need to invoke our services. In this case, the example is a sentiment analysis. Set some parameter, our Azure subscription key, and then send the request to the service, and we will get a result. Nothing more simple than this. Second way, still easy, but some more work. Announced that built 2018, we have custom cognitive services. This means that we are given the ability to customize general services to our specific domain. What does this mean? For example, for vision, we can take some set of our pictures so that then it can recognize me, my colleagues, my family. So it's customization service. How to do that? It's really simple. Just go to the Custom Vision AI site, create a project. If we want to make the classification, then the project type should be classification. Classification type multi-class, because we want to classify several different domains, different elements. And if we choose as domain any that is compact, we can then export it to a lot of stuff that I will show you later on. So once we have created the project, just drop your figures. In this case, there are just some fishes, some flowers, and some sticky figures. Let's train our model, we get the result. If we are happy with the result of the precision of the trained machine learning, we are good to go, and we can export, as I told before. We made a compact and in the project, and then we can export it to ONNX. What does it mean? It means that then we can use it, for example, in our UVP application. And to use it, again, it's very simple. Just download the model, put it in our project, and the project will automatically generate all the class and code need to invoke the ONNX model. So we have just to load the model. And then in this case, it was just for recognizing shapes. So it's like we are reading with the pen on the in-canvas a shape, and then it gets recognized. To recognize it, just some lines of code to get the stroke collected from the in-canvas. Inker is just of type in-canvas, sorry. And then transform it the way that the model can evaluate it and get the result. Okay, how is possible that we can run artificial intelligence actually in our client, whatever it can be? It can be a server, it can be our Xamarin, it can be our UVP application, thanks to Windows ML. Windows ML is another piece of technology developed by Microsoft that helps us using artificial intelligence without the need of going deep in the core stuff. For example, with the artificial intelligence, we can focus on our domain. So, and what this means, that we can use our model without thinking how to make it works. To make it works, it should the model, when it when it is asked for a prediction, it can be that it has to run against the CPU or against the GPU. With WinML, all this stuff are done under the hood. We don't have to care about it. We have just to get our model, and there are also lots of already trained model that you can find online. At the end of the course, I have a slide with all the links that I collected during these years that you can get and use it. So there are also a list of lots of already trained model that you can use. So as I say, also all the things related to the hardware, we don't have to care about it. Everything is carried by Windows ML. So that's kudos to Microsoft also for this great piece of technology that we can use. If you want to get started with NNX, just go to the site and go to see the getting started in the tutorials, because one of the other important feature of Onyx that you can experience is that around the world, if you look for models or machine learning, deep neural network models, or how to develop it, usually they are developed with several different frameworks, like TensorFlow, Conf, or something else. With Onyx, with the project Onyx, there is also the way for exporting project made with other SDKs to Onyx, and then you can run it on your systems. So if you want to get if you want to get this, you can also train your data on the cloud. You can also use ML tools, WinML tools, and as I said, you already the custom vision AI site. Okay, and these are the first two ways of using AI, but we are not really developing AI, we are just using it. And so if you want to dig deeper and get our hands dirty and write our artificial intelligence code, we have to go through some process. First of all, we have to understand the core concepts, terminology and algorithms of artificial intelligence, so that then we can develop our first deep learning application. So again, which is the way to develop an artificial intelligence? We need a set of data. Actually, we need a lots of data to build and train the model, and then we can deploy it. We can use it, and we can deploy it also with ONNX. Let's go a step back to build the model and to train it. Before some months ago, before WinML, before ML.NET was developed, was released, before the Visual Studio tools for AI was released. As a .NET developer, the way to develop artificial intelligence was to go totally out of our comfort zone. We need to use Python, we need to use tools that we are not used to. Thanks to the AI tools for Visual Studio, we are able to run and build artificial intelligence using the toolset, using Visual Studio, actually, the toolset, and there is also an AI tools for Visual Studio Code. So using the tools that we are usual to use nowadays, every day, as .NET developer. Then to train the model, we can use our local hardware, or we can train it on some custom dedicated virtual machine on Azure with a lot of computational power related to AI. So that means lots of GPU power. So let's get a step back. Prepare the data. What this means, prepare the data? Prepare the data, it means first to identify the attributes of the things you are trying to classify. If I'm trying to classify fruit, maybe the features, the attributes that I need are color and weight. Dimension usually refers to the number of attributes. So in the case of color and weight, we have an attribute with 2 dimensions. So feature or attribute is one particular type of data that generally is called data points. So one data point identify one object, in this case a fruit, and it contains many different attributes, and usually the attributes they are a lot. Once you know feature to use, then the challenge is to find enough data to train the model. Imagine you need to recognize cat. You may need 10K sample image for cats if you want to get a good result. So regarding data, depending on the problem you are trying to solve, where you are trying to infuse AI, data can be anything. Can be database rows, can be sound sample, can be video sample, can be images, can be tests, anything you need. Now there is some important to say. The data challenge and to find the right data for solving your problem is important when you are actually when you are actually trying to solve your problem. If you want to learn artificial intelligence, you don't have to care at all about it, because there are a lot of already pre-made data sets around. And again, in the one of the last slide I have, there is a lot of links, and there is covering also this part, how to get data so that you can start learning artificial intelligence. But anyways, data are really important when you are then going into production, developing solving your really problem. So, one other important thing to do, and this is related also to the amount of data, is that machine learning cannot predict stuff it doesn't know about. What does it mean? Let's imagine we want to classify animals, And we will train our system with just 2 data points. One data points with attributes name, number of legs, color, and weight. So the 2 data points that we are going to train is just dog, 4 legs, color black, 10 kilos. And chicken, 2 legs, orange, 5 kilos. Now, if we train the model just with these 2 data, and then we ask the model to evaluate a cow with 4 legs, color black, and 200 kilos, I believe that the model will predict dogs, because it only knows about dogs and chicken. So this is the best guess. There is a nice sample that one of my fellow friends from the AI team was telling me, and she has a daughter, and they were usual with dog because they have a dog at home. Then they moved to Seattle. He was joining Microsoft, and there was lots of horses around. And her daughter come to him and say, hey, daddy, here there are some big dogs. That's funny, because she never saw an horse. So the father has to tell her, no, darling, this is not a dog, this is an horse. So that then the brain is trained, and he also understands how to recognize and differentiate dogs from horses. So there are several ways to train a model. Usually they are divided in supervised learning and supervised and unsupervised learning. Supervised learning, and when the machine learning is trained with data, and those data are labeled. What this means, labeled? In our case, where we want to classify animals, the label will be the race of the animal. So dog, chicken, cow, etc. And then we give 3 inputs that are number of legs, color, and weight. We are telling the system what label we do expect. We use ML in this data to predict future unseen data. So what it means that we can we have a boundary. We can represent, if we can represent it in a 2-axis dimension, we will have a boundary, and the boundary can be a straight line, a curve, or whatever, a function, let's say. And if the label is dog, should be a circle. If the label is chicken, it can be red crosses, or we can add a lot of more domains. So we were saying labeled data, and then we have unsupervised learning. Unsupervised learning is when we are developing artificial intelligence, and machine learnings learns from an unlabeled data set. So we have, imagine we have some points on a graph representing 3 different things, and the machine learning system must recognize itself that there are 3 different clusters, and it has to categorize itself. This is tricky because the number of clusters may not be known in advance, so it has to take the best guess. Sometimes also the cluster is not clear as the one we have in the picture below, so the best guess can be also not that good. And so when we are talking about unsupervised learning, also another concept is the way of training data. It can be reinforcement learning. So learning by trial and error, rewarding and punishing the system. What this means? This means that machine learning, in the case of video games, on teaching itself how to play video games, learn by playing the games millions of times. And the system is rewarded when it makes a good move. When it loses, we give him no or negative reward. Over time, over millions, billions iteration, machine learning learns how to maximize rewards without the human explicit telling them the rules. It can lead to better than human performance when it finds the path that no one thought of doing before. And this is really, really amazing. So, there are many ways that machine learning can learn pattern to classify data, as we said. In this example, we use a line to divide two clusters. When we can predict future data, saying anything above the line is owned by a cluster, anything below the line is owned by another cluster. But we can also use a cubic curve, as we saw before. So instead of a straight line, we can have a cubic curve, as you see in the picture below. And that way the machine learning will predict future point it has not seen before by understanding in which area the point belongs. So now let's talk about neural networks. Our brain consists of something like 86 billion interconnection of neurons. Each neuron responds to a certain stimuli and passes output to another. There may be a major of them dedicated to recognize cat, some for any attributes we want, each having a different weight. The weight is the important that the feature is to the overall contributing of understanding animals, for example. When the neuron fires, if all these neuron fires, your brains tell you saw a cat. In a neural network, so a model that is loosely modeled like the brain, neural networks are used to calculate the probabilities for features they are trained to look at for. So with neural networks, we try to mimic the functionalities of a brain. Do you remember when I told you the story of the horse and the dog? That's why. That's really the so now the brain of that little girls will fire some different neurons. So this is the representation of an artificial neuron. So we have three arrows on the left corresponding to the inputs coming to the network. Let's say values 0.7, 0.7, 0.6, 1.4, and these are the weight assigned to the corresponding input. So this is the input with the weight. Input get multiplied by their respective weight, and the sum is taken. So if we consider three input, we have x1, x2, x3, and if we consider three weight, it can be w1, w2, and w3. We have then the sum of it, and after we sum, we usually add a bias, and we also swing the code this to the sum to get the sum. And the bias is just a constant number, let's say 1, which is added for scaling purposes. So the new sum will be something like this one. It's not necessary to add bias, but it's a good practice, and it's good for speeding up the process. After adding the bias, we reach the threshold step, and if the new sum calculated is above the threshold value, the neuron gets excited. So it means it passes the value, it passes out to the output. Otherwise, it doesn't. So exact. It goes there, and then it goes on the other side. Now, with this concept, this is the math behind all of this. So we are developer, we are not really caring about that, but also in my links I have a good book where to start from, and the book is actually made out of a professor of the Californian University, and when you get this book, you get also access to the full semester recordings. So it's a video recording where the professor is teaching the course based on that book. That's really good if you want to dig deep into the math of this. The activation function that we saw over there is another part of the process of the neuron, and usually there are several activation function. Usually they are used, the most used 90% of the time is the ReLU 1 or the 10H or the sigmoid. The 10H goes from -1 to 1, the sigmoid goes from 0 to 1. These are the most used, and there is something to say about this, about artificial intelligence. Artificial intelligence is so complex that it's not an exact science. The way we develop artificial intelligence is by testing. So because of this, we can apply to our neuron one activation function or another, so that then we can train the model with an activation function, get the result, train the model with another activation function and get the result, as well as using different deep neural network patterns, right? By testing the data, and getting the result, we will get the most important part. So I want to show you something about that. So let's see. Yes, it's over there. So as I told you before, there are a lot of databases out of their dataset that we're ready to use for our teaching purposes. One of the most known is the MNIST database. So the MNIST database is a database of n-written digits, and we have 70,000 labeled example and 10,000 sample that can be used to get the result. This is another important concept about artificial intelligence. When we train our model, then if we want to test it, we have to use a dataset that is never shown before. Because if you use the same data, it's like spoiling, right? It's not good to use the same data that we use to train the system for then testing it out. Okay, right? So this is another important thing. Always divide training dataset from test dataset. So here, like you can see, there are several different classifiers used to create a machine learning model. So what does it mean? We get the dataset, we train the model with one of these classifier and also with the post-processing, and then we get the result. The best result we can get is the one that then the trained model that we want to use. In the case of the MNIST database, the SQM is one of the best here. Okay, let's go back. So activation function, where we are. So, okay. We got the concept of a neuron. Then imagine that we can stack a multi-layered neuron, like it happens to the brain. And all stacking up any artificial neuron helps us to create intelligent systems. Why? Because we are talking about deep neural network, and deep neural network simply consists of interconnected layers of neurons. There are also some hidden layer in between the input and the output, and each layer can learn from the one before. This is important. hidden layer can usually are usually a lower dimension so that they can generalize and not overfit input data. Middle layer can learn features, and a simple example, it's like first layer, it's like lead to understand that is a phase part, and then the other layer leads to phases, and so far so on. The most two deep neural networks used are the convolutional neural networks and recurrent neural network. And yes, some machine learning types. We have regression, that is to predict numerical values like price of the house, classification. So if this cat, human, or whatever, clustering. Most similar other example, so for example, the related products of Amazon. And then we have sequence prediction. So if we have a sequence 1, 2, 3, 4, 5, we want to predict the next number. So we are very near to start developing our application. So to develop our application, the tools are really important. Visual Studio Tools, go ahead and go to grab it and install. There is also a sample repository on channel 9. There is a very good video talking about Visual Studio Tool, how to install and how to use it. WinML, it's something really important. It was released something like 6 months ago, I think, I believe, at Build, announced at Build. And before these two guys, as I told you, the only way to develop artificial intelligence was just to go out of our comfort zone. Now what we can do is using the Visual Studio Tools for AI and also WinML. With WinML, what we can do is to develop artificial intelligence in C#. Now, nice. And I will show you. What is the difference. We already talked about the modified National Institute and Standard and Technology database of Android and Digit, and we are going to use it for the rest of the course. And this is an important one. So let's develop our first application. So okay. So I was talking about the MNIST database, and so the MNIST database. This is another link that you will find then later in my resource. It's as I told you, is a database of handwritten digit database, and it consists of in total 70,000 images of handwritten, and these images are 28 pixel by 28 pixel. Now, one important thing that we have to do when we have sets of data that is multidimensional. And usually multidimensional data are called tensor. This is another thing to understand, is that we need to get this picture and load in a single dimensional array. For doing that, we are doing what is called fluttering. So we are going to take, so it's like, as we said, it's 28 pixel by 28 pixel. So we get the first row, 28 pixel, and we will start putting in a row. Then we get the second row, and we go and we put it on the side. On the side, by having, if you multiply 28 by 28, it comes out 784 pixel, and this is our vector that we are gonna use for such kind of stuff. Now, why I want to use, why I like the MNIST database. I like the MNIST database because it's something visual. So when we train the model, we get the result we get the result visually. We understand if the machine learning is well trained or not because the data are visual. So if we handwrite one, for example, then we ask the machine learning to get it. We can understand if it's good or not. So there is another very nice resources that I don't see. Let me find, because it's something that I want really to show you. So bookmarking tools, view bookmark sidebars. Okay, here we are. The most complex one. So let's see if I can find it very fast. Yes, this one. So this is another blog that is in the resources, and it's very good. So let's say neural networks. Where is it? Blah blah blah. Okay, fast way. Here we go. So this is a paper. This guy is researching about, and he was. The paper was based on the MNIST database. So this is the result of a study of a semester or so. And one thing that I was telling you about the data is that, okay, let's see if we can visualize it, because it's very nice. So it's getting a bit longer to load it, but it's loading. So why it's good to use visual data when we are starting understanding artificial intelligence? This is a 3D representation of the MNIST trained model with one of the models that we are going to use. And so here you can say any of this point is the point used to train the model. And what we can experience over there, this is an 8, but this is in the context of an 8, okay? So this is an 8 in the context of a 6, right? Why? Because it really seems we are not sure if it's an 8 or 6, and this is where the artificial intelligence maybe can file, right? This is a 5, but it seems, yeah, right? You see, it can be, and so let's see. Now that said, let's see some example. So. As I told you, Visual Studio AI tools, they have a very good sample repository where you can find a lot of example for different SDKs. Okay, so okay, let's do it like this. Now I cannot find the source on my laptop, but you can go online, and also in the list of resources I will give you, there is also the link for the sample. Here it is, for the sample AI master. So this is the MNIST database implementation using actually the CNTK SDK. So, and this is Python. So we are already in our comfort zone because we are using our tool, right? But this is Python. So it's a step ahead because we don't have to use other tools. So kudos to the Visual Studio AI tools for the team that developed these tools, but we are still out of our comfort zone. Nevertheless, I want to show you, this is the most important part of the code where they are creating with this code we are creating the deep neural network for then creating the model and then train it. So if we run this code over there, so the code, as you can see over there, it's okay. Wait, the breakpoint. Yeah, we can also use all the features we have in Visual Studio. That's fantastic. So it's creating the model. We are adding some layers to our deep neural network. Do you remember the slides where we was talking about the things, the layers on the deep neural network? This is creating the layers for the model, and then the data gets downloaded. I have already done locally, so hopefully it's not going to download it. And then exactly, let's go there, and then okay, exactly, it's going to train our system. So we are actually training the AI model. I want to show you my task manager, but it gets a bit, how to say, yeah, here it is. Let's get a bit, okay, let's stop this. We already have the result. So we have the result, and the result we can get over there. Open. Okay, we can open in File Explorer if my laptop is able to do it, and it's a bit slower down. And here we go. This is the model. The CNTK already. This is the last line of the code. Let's see. It's over there. We are running out of time. I want to show you C# samples. Okay, the Onyx model. So that then we can use the Onyx model on our component. So let's say we are a bit late. So something that I want to show you is how to do it with WinML. With WinML, just create a project, add a dependency to the WinML package, and then, for example, here I'm using the iris data. This is another dataset for classifying iris flower based on this part. So how long it is, it gets classified. So. And here we go. We can do it on C#. Just create a pipeline, load the data. The same code that we was looking at the CNTK before. Now we are doing it in C#. We can add our label. We can add our features. And then this is the most important part. We can add our classifier, and when we have the classifier, then we can also train the data and predict it. I have also another one sample that I want to show you, and also this repository is publicly available. It's also in the link in the last slide. It's in my repository. So. Again, this is a bit more complex like example, and this is what I want to show you because this is also using a regressor. So, for training the data, testing the data, we can read it, and then we can train our model. We can evaluate the result, and then use our model. This is really simple. Let's start it. So, but there is something else that I want to show you before the ending. Let's see. Come on. Okay, coffee break. Okay, right. Okay, train the data and the prediction is this one. So we got our data trained. Also from WinML, there is a way for exporting it to the Onyx model. And once we have it to the Onyx model, oh sorry, once we have it to the Onyx model, that's something for the work. I don't need it now. Once we trained it we trained the Onyx model, let's just drop it. So I have trained this model with CMTK, and this is the MNIST database, just because I didn't have the time to add the sample for the MNIST database on WinML, but I will update also this repository with also this sample. And then what we have to do is just drop the ONNX package, ONNX file over there. When you drop over there, the Visual Studio already create all the classes you need to use the classifier, and then you are good to go and use it. So, this is the part, right? As I show you in the code. This is the model, but keep in mind, this is the model that we developed now. So this is the real difference. We have developed our model, we have created our deep neural network, and now we are going to use it. So let's say you can look at the coder by yourself. So it's loading the model. I can write something over there and then say recognize, and that's it. If you want to see the process, it's really simple. Let's do it like this, erase, and let's make a 7. Recognize. So recognize. What I'm doing over there, I'm getting the stroke from the ink canvas, converting in the way the model input likes the input. I'm passing to the model, and I'm asking to evaluate it. When it's evaluated, I get the result. In this case, it's a bit complicated, so I get an array with all the guess, and I have to understand which is the best guess. I'm just iterating the array and getting the best guess that in this case is, let's say, in this case, it's a 6. Okay. This time the model wasn't that good in recognizing it, but let's give another try, and let's see what's happening over there. So evaluation, blah blah blah, and now it's 8. Okay, we have infused artificial intelligence in our application. That's almost all. We are over there, and all these resources will be available for you to download. Also, the slide will be available to download, so you can get also all the resources. As you can see, there are a lot of good points to start. One thing that I want to point you out is this one. This is 3.5 hour courses on theory about deep learning. You must see this course, and also let's see, and that's it. Some thanks for the people that helped me and get me inspired for this course and to teach myself artificial intelligence, because this is something really, really hard at the beginning. I hope this will help you. And so if we have any question, this is the moment we can get them.
All right, I think we're back.
You mean the one with the resources, I think. Yes. Absolutely, absolutely. Thank you all. Thank you.